Because they're difficult to divide by, we don't like to leave any radical expressions in the denominator of a fraction. So in order to get rid of those radicals in the denominator, we do something called rationalizing the denominators, or basically turning those denominators into rational numbers as opposed to irrational numbers. And the procedure is very simple. What we're going to do is multiply the entire expression by the number 1 in a form that will eliminate the radical in the denominator. So for example, if we have radical 1 over 3, we can think of this as radical 1 over radical 3, and remembering that the square root of x times the square root of x equals x, we can multiply this entire fraction by radical 3 over radical 3. What this will give us is radical 3 times 1 in our numerator, which is radical 3, and radical 3 times radical 3 on our denominator, which is radical 9, which we can simplify to 3. And now we've got an equivalent fraction. Radical 1 over 3 and radical 3 over 3 are equivalent fractions. Let's take a look at another one. Here we have radical 4 over radical 5. Now we can simplify before we start, we can simplify afterwards. It really doesn't matter. So let's split this into radical 4 over radical 5. And now I'm going to multiply this fraction, or this fraction, by radical 5 over radical 5, which of course we know is equal to 1. And that's going to give me radical 4 times radical 5 in my numerator and 5 in my denominator. But of course I know radical 4 is the same as 2, so I'm going to simplify that just a little further to 2 radical 5 over 5. And just be very careful. You cannot eliminate these factors, radical 5 over 5, by saying that they're equal to 1, because they're two very different numbers. This up here, radical 5, is the square root of 5. The number in our denominator is 5. So our final answer would be 2 radical 5 over 5. And if you're unsure, you can plug both expressions into your calculator, 2 radical 5 over 5 and radical 4 over 5, and you should get equivalent expressions if you've done your simplifying correctly. Let's look at a couple more examples. So in our first example, we have 8 over the square root of 24. So what I'm going to do here is I'm going to simplify my denominator first. And I know that 24 is the product of 4 and 6, 4 being a perfect square. So I can simplify this further to be 8 over 2 radical 6. So now what I'm going to do is I'm going to multiply my numerator and my denominator by radical 6. And I will get 8 radical 6 over 2 times 6. And further simplifying, let's see, well, 8 divided by 2 is 4. So let's just bring that down, 4 radical 6 over 6. And I'm just going to simplify that just a little further. So 4 is 2 times 2. 6 is 2 times 3. 2 divided by 2 is equal to 1. So I'm going to get 2 radical 6 over 3 will be the equivalent expression with no irrational numbers in its denominator. Now what happens if we have a cube root? Well, we have to do the same thing. We need to get that cube root out of the denominator. But what we're going to have to do is multiply that denominator by whatever factor will give us a perfect cube that we can take out from under the cube root. So just for illustration purposes, I'm going to expand this. I have the cube root of 9, which is 3 times 3. So I've got 2 factors of 3, but I need 3 factors of 3, or 3 factors of the cube root of 3, excuse me. So I'm going to multiply my entire expression by 1 in the form of the cube root of 3 over the cube root of 3. And the result of that multiplication will be 4 times the cube root of 3 over the cube root of 3 times 3 times 3, which is, of course, 27. Now I'm going to take the cube root here, and so what I'm left with is 4 times the cube root of 3 over 3. I have rationalized my denominator by taking the cube root of 3 out of the denominator. Now sometimes we don't have a monomial radical, but a binomial radical in our denominator. So how are we going to deal with that? Well, before we look at that, let's take a look at this product. A minus b times a plus b, when we multiply them, will of course give us a squared minus b squared. So we know when we multiply two binomials that are identical except for the sign in the middle, we get rid of that middle term, right? Because what actually happened here was we have a times a plus a times b minus a times b minus b squared. And these two terms add up to 0, so we'll get a squared minus b squared. Well, we're going to use this property to get rid of binomial radicals in our denominator. Now these two factors, which are identical except for their sign, are called conjugates. And we're going to multiply, in order to get rid of our radical in the denominator, we're going to multiply the denominator by the conjugate of the denominator. So the conjugate of this denominator would be 4 plus radical 3. So I'm going to multiply my entire expression times 4 plus radical 3 over 4 plus radical 3. So here we go. In my numerator, I'm going to get 4 radical 3 plus radical 3 times radical 3, which is 3. In my denominator, now I've got to distribute, so here we go. I'm going to just write this out. It's going to, what I'm having in the denominator here will be 4 times 4 plus radical 3 minus radical 3 times 4 plus radical 3. So let's just simplify this. Here we go. We're going to get 4 radical 3 plus 3. That's what's in our numerator. I'm going to get 16 plus 4 radical 3 minus 4 radical 3, and then negative radical 3 times positive radical 3 will give us minus 3. And so finally putting it all together, I see that these two terms will be 0. So I'm going to have 4 radical 3 plus 3 over, now I have these like terms, 16 minus 3, which is 13, and this is 0. So again, the procedure was to multiply my entire expression by 1 in the form of the conjugate of the denominator. So here's your guideline. To rationalize a denominator that contains a binomial, multiply the entire expression by 1 in the form of the conjugate of the denominator divided by itself. And remember, the conjugate is just the same binomial with the opposite sign. So let's do one more example. Let's try this. 3 over radical 5 minus 2. So what's the conjugate of radical 5 minus 2 going to be? That's right, radical 5 plus 2. So I'm going to multiply my numerator and my denominator by radical 5 plus 2 over radical 5 plus 2. So here we go. I'm going to erase this down here so we have room to work. So first I'll just distribute the 3 over both of these terms. So I'm going to get 3 times radical 5 plus 2 over radical 5 minus 2 times radical 5 plus 2. So that's going to give me 3 radical 5 plus 6 when I distribute this 3. And now let's just begin distributing everything here. We're going to have radical 5 times 5, which is 5, plus 2 radical 5. Now, minus 2 radical 5, and then negative 2 times positive 2 will be minus 4. Now we can simplify. We're going to get 3 radical 5 plus 6 in the numerator. Radical 2 radical 5 minus 2 radical 5 is 0. And then I get 5 minus 4, which is 1. So my answer will be 3 radical 5 plus 6. No denominator, no radicals in the denominator.